Okay, for bell work today, we got this really kind of complicated problem that we skipped last time. So you're on a boat and you travel from port A due west at 20 knots, which is 20 nautical miles. A nautical mile, by the way, is 1.15 miles, so it's just a little over a mile, which means after 2 hours, you are now 40 nautical miles west. At 2 p.m., point B here, you change your bearing to north 54 degrees west, as shown here, and you continue traveling for another hour when at 3 p.m. your boat breaks down. Oh no. You need to find your bearing and the value of C so that you can let the Coast Guard know how far you are from port A and in which direction. To do that, you will need to find angle A using trigonometry with this large right triangle. But before you can do that, you need to know at least one side value. And this problem, really two side values, since you don't know the other angle. And so the easiest way to do that is to find the value of B and D here using trigonometry with this smaller right triangle here. And the first step to do that is you need to tell me if this is 54 degrees, what is this angle right here? And then you should be able to use that angle and the hypotenuse of 20 to find B and D. And then you should be off to the races. I'll give you 3 minutes to start working on this and see how far you can get. And then we'll go over it. Okay, let's go over this. So, okay. Okay, so to start off with, first thing we need to find is this angle right here. What is this angle? Straight line right here. This is 90. So this has to be 90. If this is 54, how much is left over for this angle right here? How do I find this amount? You can unmute and say it or put it in chat. Either's fine. That's right, Jackson. That's right. Thought I saw you unmute for a second. Yeah, you're right. So this is 36 degrees. You just do 90 minus 54. All right, so then we can use that to solve for B and D. This would be the opposite side from that angle. We already said 20 was the hypotenuse, and D would then be the adjacent leg. So if I want to find the opposite given the hypotenuse, which trig function relates opposite and hypotenuse? Sine, cosine, or tangent? Not quite. Tangent is opposite over adjacent. You're close. We want opposite over hypotenuse.
Sine.
There you go. Yeah. So we got the sine of 36 degrees is opposite B over hypotenuse 20. Solve this for B by multiplying by 20. So B will be 20 times the sine of 36 degrees. Type that into the old calculator, and we get 11.756 nautical miles. Whoop, 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 whoop. To find D, similar idea. We're trying to find the adjacent side given the hypotenuse. And adjacent and hypotenuse are related by cosine. So we can write the cosine of 36 degrees is D over 20. How about that? Multiply both sides by 20. We get D is equal to 20 times the cosine of 36 degrees. Multiply those together. 20 cosine of 36 is 16.180 nautical miles. Note that this is to tell the Coast Guard where to come. The 10th of a mile is a lot. 100th of a mile is still is close. But if you go to 1,000s, then they'll definitely know where you are, minus any drift. So now that we know B and D, we can find what we're really looking for. C. And to be honest, to find C, we don't even have to use trigonometry, right? This is a right triangle. And if you know two sides of a right triangle, you can find the third side with your good old buddy Pythagorean theorem. A squared plus B squared is equal to C squared. So we can write C squared is equal to A squared, which we said was 11.756 plus, okay, note that this side down here, the base, is not just 16.18. 16.18 is this distance from C to B. We want to go C all the way to A. So it's really 56.180 squared, which means C is the square root of that. And if you use the copy and paste functions in your calculator, you can get this a little bit more accurately by scrolling up to your previous answer and hitting enter. It'll copy the whole decimal rather than where we rounded. And if you do that, you get about 57.397 nautical miles. Okay, so that's C. To find our bearing, we need to find angle A. And to find angle A, again, we're going to label our triangle opposite, adjacent, and hypotenuse. And to be honest, it really doesn't matter which trig function you use since you know all three sides. You can use sine, cosine, or tangent. I'm going to go ahead and use tangent. The tangent of angle A is the opposite side, 11.756 over the adjacent side, 56.18, which means that A is equal to the tangent inverse of 11.756 over 56.18. And again, if you use the copy and paste features of your calculator, then you can get this answer with a little bit higher degree of accuracy, which is again, is really important because your life is on the line. You are shipwrecked. Your boat isn't working and you're 50, probably about 60 miles off of shore. Okay. So A is about 11.819 degrees. And again, it's really important that you go as far out to like the third decimal place because a tenth of a degree over 60 miles is huge. That's a big difference in the actual location of your ship. 100th would probably satisfy for this problem. But if you go to 1,000th, then you're confident they will know exactly where you are. Now, the only issue is, again, that's not our answer. We need our bearing. So that's this amount right here. How do I find this amount? How many degrees west of north is that? Okay. Remember, this is a 90-degree angle, right? 90-degree angle here. If this is 11.8, about how much is left over for this month, for this angle? You can unmute or you can put it in chat. This angle A is 11.8 degrees. How many degrees west of north is this? What do you think, Gavin? Caitlin? I haven't heard from you two yet. What do you think? That's close. I think you're 10 too high. But yeah, you're on the right track. I think that's probably a calculate. Yeah, there you go. Yeah, 78.2 degrees. That's right. Because again, you just subtracted from 90. And again, if you use the full decimal, that'd be really 78.181. So then you can get on the horn and say, breaker 19. We are aboard the SS Honors Precalculus and have broken down 57.397 nautical miles at a bearing of north 78.181 degrees west. Asking for assistance, please. We are almost out of sandwiches. And imagine if you were an honors pre-calc, right? You wouldn't be able to even get close to giving them that information. And so you'd have to be like, hey, we're somewhere northwest. If you pass the three, you'll pass 3 seagulls on the way. Hell. And then they'll have to do a grid search for your boat instead of being able to go directly to it. And then they're not going to arrive until after you've had to break into the ham and cheese platter. And you were supposed to save that for the second day of your vacation. So it's a good thing you took honors pre-calculus, right? All right, let us talk about what we're doing today. So today is kind of an easy day, kind of a hard day. It's easy in the sense we are reviewing. We are doing stuff that we've already done in this class. The hard part is we're going further and we're doing harder versions of those problems. So we're back to using our trig identities to solve problems. And we're going to use those trig identities, as I said, in 3 ways. One is to evaluate different trig functions. 2 is to simplify, and really going hand in hand with that is to rewrite trig expressions. So the first thing we're going to talk about is what are the trig identities again? This is already in your notes, so you don't need to write it down again. You can take a picture of it if you like. But remember, there are 5 families of trig identities we've covered so far. The reciprocal identities, sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. Our quotient identities, which you're going to use a lot in this chapter. The tangent is sine over cosine. Its reciprocal cotangent then is cosine over sine. The Pythagorean identities, which again are used to, actually I feel like quite a lot. It's a favorite to go to. The Pythagorean identities state that sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. We didn't use these last time we were doing our simplifying trig expressions and proofs, but these are really not that hard. Remember your cofunction identities that sine and cosine have the same graphs. They're just translated by pi over 2 radians or 90 degrees left or right of each other. That same relationship holds with tangent and cotangent and secant and cosecant. Finally, your even odd identities. Remember that sine cosecant, tangent, and cotangent are odd functions. They have symmetry about the origin, which means their answers in the first and third quadrants are the same, and the answers in the second and fourth quadrants are the same. So as a result of that, the sign of a negative angle is just the same answer as the negative sign. You basically reflect it over the y-axis and then the x-axis, and you'll get your answer. Cosine and secant are even functions. They are symmetric only about the y-axis, which means negative values, negative angle values have the same answer as their corresponding positive angle value. So the cosine of a negative angle is the same as the cosine of that positive angle. Again, these aren't that bad to use. And to be honest, if you see a pi over 2 in your problem, then you'll probably use a cofunction identity. It'll be pretty clear to you then that that's what you have to do. And if you have a negative angle inside any of your trig functions, that's a strong hint that you're going to use its corresponding even and odd identity. All right, so now that we've talked through these again, let's do some review. So the first thing, evaluating, is not so bad. We just went over this shortly ago. So we're going to go straight into a guided practice for this one. If the secant of an angle u is negative 3 over 2, and the tangent of u is greater than 0, tell me what all 6 trig functions equal. I'll give you 3 minutes to work on this, and then we'll go over it. And I'll give you a hint after every minute. Okay, first hint, remember secant of an angle is r over x. So according to this problem, r is 3 and x is negative 2. So you need to find what is y. Okay, so let's start going over this. So the first thing really you should do is draw a picture and determine what quadrant your angle should be in. We know that because x is negative, it has to be in quadrants 2 or 3. Because tangent is positive, the only way that could occur is if y is also negative. That way you do a negative divided by a negative makes a positive. And the only place y is negative is below the axis in quadrants 3 and 4, which means the angle must be in quadrant 3. How can I find the value of y for this right triangle? What do I need to do to find y? Yeah, the Pythagorean theorem. A squared plus b squared is c squared. So what we'll get is y squared plus negative 2 squared is 3 squared, which means y squared plus 4 is 9, which means y squared is 5, which means y is the negative square root of 5. Remember, y has to be negative. We're in the third quadrant. So I'll tell you, if you end up getting any of the problems wrong for these type in WebAssign, the most likely thing that messed you up is your signs. All right, the sine of an angle is y over r. So then our answer would be negative square root of 5 over 3. The cosecant is the reciprocal of that, which WebAssign will accept that as an answer. Though in the ACT, the answer would look more like this when there's no radical in the denominator. Secant we already had was negative 3 over 2. If you take its reciprocal to get cosine, you get negative 2 over 3. Tangent we said was y over x, so that's negative square root of 5 over negative 2, which is the square root of 5 over 2. And its reciprocal then would be 2 over the square root of 5, which is fine for WebAssign. ACT, they'd probably more likely put the answer as 2 square roots of 5 over 5. All right, questions on this? Or does anyone need more time to write? Okay, and let's talk about, so that's evaluating. Now let's talk about simplifying and rewriting. For simplifying and rewriting, there is not a set steps that you have to follow. And there are a lot of different ways you can answer that. So that's what makes these kind of difficult. Here are my guidelines. The first thing I always try to do is simplify my problems using your algebra skills. So combining like terms. And you might have these in your notes from when we did this type of problems earlier. Probably wouldn't hurt to rewrite them. And then factoring and distributive property are the two big things you might look out for. If that doesn't work and you're not getting down to a single term of a single trig function, then the next thing I would try doing is rewriting your problem in terms of sine and cosine using your reciprocal and quotient identities. And then go back and try simplifying with your algebra skills some more. If you still have not reduced it to a single term of a single trig function, the next thing you should look for is if there are any other identities I could use. Common things to look for. If you have a trig function squared, that means that you probably need to use a Pythagorean identity. If you have a pi over 2 inside the angle of your problem, that means you probably need to use a cofunction identity. If you have a negative angle, that means you probably need to use the even odd identities. So for example, let's try applying these guidelines to this problem. Notice I can't combine like terms here because my two terms are not alike. This first term has a cosine squared. However, I can factor it because both of the terms have a sine of x in them. So if I factor out the sine of x, then my first term will just be cosine squared. And my second term, sine divided by sine, is 1. All right, I'm still not down to a single trig function yet. And everything is already in terms of sine and cosine. So is there any other identity I can use? And hey, look, I have a trig function squared. So I'm probably going to have to use a Pythagorean identity. Which Pythagorean identity has cosine in it? The very first one. Sine squared plus cosine squared is 1. Which means that cosine squared is just 1 minus sine squared. So if I plug this in, the cosine squared, then what we'll get is the sine of x times 1 minus the sine squared of x. And now if I go back and simplify this, 1 minus 1, hey, that's 0. That cancels out. And sine times negative sine squared is negative sine cubed. And now I'm down to a single term with a single trig function. So again, this is just like you were doing when we had to like show this trig expression is equal to this trig expression. The only difference now and why these problems are harder is because they don't tell you what the answer is going to be. You're still using the same skills, same steps, but at the end of the day, you don't know if you have simplified it enough or if the answer you got is right. One thing you can do to be a little bit more confident in your answer is you can verify that nowhere in your process did you mess up what the expression is. And you can verify that by graphing. So if I graph sine cosine squared minus the sine of x, and my answer, the negative sine of x cubed, you can see that those two graphs are identical. So at least I know that the answer I have is an equivalent expression. You still might get in trouble if you haven't simplified it enough. If there's more things you could do to simplify it. All right, questions on A, or really anything about this process. All right, let's try another one. Try B. So if I can't combine these, they're not like terms, and I can't factor anything out because they're all different trig expressions. So what I'm going to do is rewrite this in terms of sine and cosine. And I know that the cotangent, according to our quotient identity, is cosine over sine. So if I plug this in for cotangent, what we'll get is sine of t plus cosine times cosine is cosine squared over sine. And now I have two options of how I can continue this problem. One is I can combine these together by getting a common denominator. Or I notice that I have a cosine squared, so I can use my Pythagorean identity. Either choice you make, you will get the right answer. Let me show you how to combine these. So if I get these as a like term, or get them to have a common denominator, I need to multiply this denominator by sine. And I would have to do the same thing to the numerator. And so now I can combine these into one term of sine times sine is sine squared plus cosine squared. But sine squared plus cosine squared is just 1. So according to our Pythagorean identity, this is just 1 over sine. And 1 over sine is just cosecant. That's your reciprocal identity. And so now I'm down to a single expression, single term of a single trig expression. Questions on B? All right, I think we'll skip the guided practice. If you need more practice, you can try this one. There's the answer to it in the notes. There are some more factoring examples that I didn't get a chance to go over that I think would probably be useful for the homework. So you can read about how to do those problems on page 354 of the textbook. Or if you look at the lecture notes for subpoint B5, the factoring examples, I walk through step by step how to do these three. I would encourage you to use either of those resources. And don't forget that you can also use the videos in WebAssign to get more instruction on that. Otherwise, that's the end of class. On Wednesday, we'll have a short quiz over 4.7, both parts, 4.8 and 5.1. We'll do one of those factoring examples of spell work on Wednesday. And then this assignment and the quiz are due Wednesday at midnight. So don't wait. Use your time today, use seminar tomorrow to kind of get started and think you'll be fine. Questions about any of that? All right, then have a good day, everybody. And I'll see you Wednesday.